it, so I'm just redoing it.
Okay. All right.
Yes.
But you're are you currently enrolled in an institution?
No, I'm actually working.
Oh, whoa,
Yes.
whoa, whoa. Okay. All right. Welcome. All right. Thank you.
All right. Thanks as well.
Yeah, man. All right. So, in case you're just joining us, we're just checking out. Oh, I must apologize if you hear any noise in the background. It's some construction going on. Um, this might happen for quite a while, but I hope as it gets more and more, it get less noisy and noisy. But you know that in the initial stage of any construction is always noisy. All right. All right. So, Miss Moore, you may put your hand down. All right. You know. All right. Thank you. All right. So I am sure Mr. Green would have mentioned to you that starting next week we're gonna switch to Zoom. One of the reasons is that I've been getting complaints, and I myself had have problems with Google Meets. Is that whenever we record the session, what you see on YouTube, you don't see the entire screen. It's like 75% of the screen you're actually seeing, or you see only 75% of what I'm doing. And if you have a small device like a phone, or it's going to be very difficult to actually see what's happening on the screen. All right, so that's the reason why we're going to switch to Zoom. And Mr. Green would have sent you the link, and he told me that maybe sometimes we have to switch back to Meet because it's a heavily used platform. All right, so the only problem I have with Zoom is that sometimes it takes a lot more data if you're using data. All right, and one of the reasons why Zoom takes a lot more data is because Zoom is operating entirely in the cloud system of storage. All right. All right. So that's one of the reasons why. All right. So let us start. Now, last week we were looking at Pythagoras' theorem, and I can't remember if we actually started any trigonometry. All right. So what I'm going to do, we're going to scan through what we learned last week and then move on to basic trigonometry. All right. Okay. So all right. So I'm going to share my screen now. All right. Tell me if you are seeing a PowerPoint presentation.
Yes, sir.
All right. Okay. So for those of you who don't know me, this is how I look. And I must apologize about not having my camera up. Okay, what's happening here? All right, so these are the objectives you probably get in any class that speaks to Pythagoras. All right, so remember that we're not going to go through in depth with this because we covered this last week. All right, so with Pythagoras, there are a few things you should know. You should, we talk about the hypotenuse, the right angle. What is the Pythagoras theorem? Square root, square of a number. And in Pythagoras, we find the missing lengths of sides of right angle triangle using the theorem. So essentially, Pythagoras theorem only deals with finding unknown sides. And there are a few practical applications of Pythagoras theorem that we mentioned last week. All right, such as in construction, among other things. It also can be used in aviation. All right, and here we have objectives for trigonometry, but I'm not going to go through that right now. We're still on Pythagoras. All right, so let me just find the notes. All right, so essentially, this is the right angle triangle. And as you see that the hypotenuse is always opposite the right angle. The hypotenuse is the longest side of the triangle. And let me just repeat this again. It's always about a right angle triangle when we deal with Pythagoras. And we have different types of triangle. All right. Can somebody give me 2 different types of triangle?
Acute.
Mm-hmm.
You have isosceles.
Isosceles, right? Right. And
Scalene.
scalene. Give me one more. Just one. It starts with an E. Right. Equilateral triangle. All right. So you have different types of triangle, but Pythagoras only works with what? Right angle triangle. Right. And how you know it's a right angle triangle? Because it must have a what? 90 degrees. Right. Very good.
90 degrees.
Right. And here we had to explain that Pythagoras only find what? Unknown sides. If the other 2 sides are given. All right. And and these are the formulas. So basically, essentially, the formula is what? If C is a hypotenuse, right? Therefore, A and B would have been the 2 short sides. So essentially, Pythagoras basically states that if you sum, I'm over on the right hand side. If you sum the squares of the 2 short sides, you're going to get the square of the longest side. Let me say that again. Essentially, Pythagoras theorem is really the sum of the squares of the 2 short sides, and the 2 short sides are which sides? A and B. So if you sum the squares of the 2 short sides, you get the square of the hypotenuse or the longest side. And we can rearrange the formula to find the short side. All right, so a quick example here. So we're given 4 and 6. Now 4 and 6 would represent the 2 short sides, and A would be the longest side. So A square is equal to the sum of the squares of what? 4 square and what? 6 square. All right, I want to know what 4 square is what? 16.
4 times 4.
Right, I want to know what 6 squares is 36. All right, and I want you guys to take out the calculator. What's the sum of 16 plus 36?
52.
Very good. All right. Now, so over on the left hand side here, so you'll have A square equal 52. But we don't want A square. What do we want? A. So we're going to square root the left, and we're going to square root the right. And when you find the square root of a square, it vanishes. All right. Let me see if I can bring up my marker here. is it? All right, so right here, so should have been what? A square, and that is a square. But we don't want a square. What do we want? We want a, so we find the square root of a square. And if we find square root on the left, we find square root on the right. Now, when you find the square root of a square, it vanishes. So therefore, a is equal to the square root of 52. All right? Can someone tell me what the square root of 52 is? To one decimal place.
Sir, I have 7.2.
You have 7.2. All right, very good. 7.2. Very good. All right, everybody following? Is there anybody lost?
No, sir.
All right, okay. I'm going to give you something to do, you see? I'm going to change up these values. Hold on. Okay, let me use my marker here. So I'm going to change this 4 to 36. I'm going to change the 6. Hold on. All right, I'm going to change it to 77. All right. So find the value of A now. So I'm using different values. Let me write the 36 a little bit better. All right. You're supposed to get a nice whole number. But you're going to have to use your calculator though.
Sir,
Mm-hmm.
85 points.
85? 85?
Yes, sir.
Okay. Anybody else? Would you agree with Audrey?
Same thing, sir. 85.
Very good. It is, in fact, 85 centimeter. All right. So, and you use the same formula. All right. Let me ask a question. Suppose I want to find a short side because the a square, the a square represents the long side. But what if I give you, say, let us say you got 85 here, so you got 85, and I give you 36, and I ask you to find this side. Well, we know it's 77. How would you manipulate the formula to find a short side? All right, so that's what we're going to look at next.
Sir,
Yes?
you would do the a square times the b square and then minus the other side, sir. Or the a square plus the c square minus the b square, sir.
Very good. Right, right, Audrey. You're correct. Absolutely correct. So basically, what happened? Let's go back here. I think I would have given you the formulas, right? So they're up here, don't you? Oh, I think something is wrong with this formula. I think something is wrong with this. Is it right? We have c square, a square, and b square. No square should be there. Here, it should be just c. So a and b would represent the short side, don't you? So I know this is the formula. C square subtract b square. So c square would have been the longest side. All right. And if you want to find the other side, b square, use the same formula, but the letters jump around. Can somebody tell me the differences between finding a long side and a short side in terms of the formulas? Remember, the a square, b square represents the short side. And hold on, guys. Hold on. Hello? You reach? Where the gate? Okay, all right, super. All right, guys, give me Mr. Green. Are you there? Hold on. Yeah, man. Yeah, man. The same plate. You forget? Which have some palm tree there? Yeah, man. The gate open. Yeah. Mr. Green, are you there? All right, guys, give me 2 minutes. You see, I need to go front gate to collect something. Sorry about that. All right. Sorry about that, guys. Are you hearing me properly?
Yes, sir.
All right.
Yes, sir.
Okay. All right. So as I was saying, yeah, give me two differences between finding a long side and a short side in terms of the formula.
We subtract for one of them.
Very good. So, say that again, please. You're breaking up. All right. Hold on, guys. Sorry about that. Sorry about that. In and out, the host. All right. And then when I came back in, I realized that there's no internet. And I was here talking the whole time, talking. I'm talking to the blank screen. When nobody answered and I checked, I realized there was no internet. Okay, so yes, as I was saying, let me just move on to this quickly. The two differences between finding a long side and a short side is that whenever you're finding a long side, we add. As you can see, when we find a short side, what do? We subtract. But look carefully, if you notice that the two formulas for short side, that c square is always on the left hand side. All right. So, and that has to be because if remember c square is the longest side, right? Now, if you have c square on the right hand side, you're going to have a negative square root. All right. Now, anytime you're doing Pythagoras theorem and you have a negative number in the square root, you're doing something wrong. All right. Okay. So that's for the formulas. Right. And I gave you a question and you work it out and it was 85. Very good. All right. So let's look at a question now where, oh, it's worked out already. So in this question, you're asked to find a short side. All right. And you know that it's a short side because one, the longest side is given and the longest side is always opposite the what? The right angle. All right. So let's look at this now. So you see we have 6 square equals x square plus 3 square. just like the formula. So if you notice in the previous example, we started out with a square, and a square was unknown. But if you notice in this one, we started off with a square, but a square is unknown, which is 6 square. All right, and our objective here is to find x square. So what we do on the right hand side, we subtract 3 square on the right, and if we subtract 3 square on the right, we have to subtract it on the left. So this will go away over here. So on the right hand side, remaining what? What is left back? X square. We know that 6 square is 36, 3 square is 9, and 9 from 36 is 27. And to get rid of a square, we square root. But if we square root on the left, we square it on the right. And here we go, 5.2. And that's how you find a short side. Do you guys have any questions?
No, sir.
All right, let's move on to another one. All right, so well, we're not going to go back into this because remember we're still doing a review. We're still doing what I really want to do is to go on to some trigonometry. All right, so that was basically last class. Right, so in trigonometry, so it's a branch of math that studies relationship involving lengths and angles of triangles. So notice the difference between Pythagoras and trigonometry. Pythagoras only deals with sides, whilst trigonometry deals with sides and what? Angles of triangles. All right? And there's some information. All right, now, in a right angle triangle, we have the hypotenuse, right? And we also have something called the reference angle. And you notice we have some labels, opposite and we have adjacent. Now, we know that the hypotenuse is always opposite the right angle. And we also know that the adjacent side is always between the right angle and the reference angle. So the other side must be the opposite. All right? So labeling the sides of the triangle is very important. Let me run through that one more time. So when you get a right angle triangle, we know that the opposite side, opposite the right angle is the hypotenuse. And they're going to always give you a reference angle. Now, the side that is between the reference angle and the right angle is called the adjacent side. All right, and opposite side would be the remaining side. All right, so we have some trigonometric ratios. So for a right angle triangle, the sine, cosine, and tangent is defined as now sine. All right, so this thing keeps on vanishing. Don't know why. All right, sine is opposite over hypotenuse. All right. Can someone tell me what cos is? Anybody know what cos is?
Adjacent over hypotenuse.
Very good. Cos is adjacent over hypotenuse. Sorry about this here. Anybody know what tan is?
Sir, opposite over adjacent.
Very good. Tan is opposite over adjacent. So we have 3 trigonometric ratios. What's a ratio? Why are they called trigonometric ratio? We understand they're trigonometric, as in sine, cos, and tan. But the word ratio, what is a ratio? If I say the ratio of males to females in math class is 1 to 2, what does that mean?
So you're telling the ratio of the male to female in a maths class? Yeah.
Right. Yeah. What does it mean? No, what does it really mean? 1 to 2.
So, sir, the amount of maybe boys to girls
boys them larger, sir, than girls,
Mhm.
maybe?
All right, you have to be specific, you know. So basically, what it's saying, for every one male, you have what? Two females,
Male.
right? So if you have two males, how much females are gonna have?
One.
Four. No man. Four. It's in a 1-to-2 ratio.
Oh.
It's in a one. So male. So a 1-to-2 means it's male to female. So when you have one male, you have two females.
Oh,
So
okay.
if you have,
Sir, that go up by 2.
right. So if I have 100 males at a university, how
200
much females
females.
you have?
102. 200. Because you
No man.
say
No, we're gonna have 200. All right. Right. So it's in a 1-to-2 ratio. Now, a 1-to-2 ratio can be expressed as a fraction. A 1-to-2 ratio is actually 1/2, you know. All right. So when it says trigonometric ratio, we're talking about fractions also. All right. So as you can see, the formula for sine is a fraction. So the fraction part is what we call the what? The ratio part. All right. By the way, these formulas are given in the exam. So let me run it again. Sine is opposite over hypotenuse, or some people say so. SOH, and you have cos, which is a adjacent to hypotenuse, which is what? Car. And we have tan, which is what? Opposite over adjacent, which is which is TOA. And what's the famous acronym for all of those? For sine, cos,
Sokotoa.
right,
Krakatoa.
right. And you know, a lot of jokes. People run up, yeah, some people run be a joke with them something there. All right, so what you know? Let's look at this. So I give you a triangle, right? And I ask you to label a triangle. So if I say, okay, label hypotenuse, hypotenuse would be what?
CB.
CB, or you could say B to C, because it's opposite the right angle.
Sir.
Right. And the adjacent side is which side?
AC between the. What does that mean again? And the right angle.
It's between the right angle and the reference angle.
Yes, sir.
And the other side would have been the opposite. All right. So guess what? Guess what I'm going to do now? I'm going to draw a little triangle and you label it. All right. So, oh, this thing working now. Let me see how I go now. Oh my, hold on there. All right. So a while ago I had a power cut. Did anybody experience a power cut also?
Yes, sir.
Okay.
No, sir.
No? Okay. All right. Who that? Jodian?
No, sir.
Okay. All right. So that's my triangle. I'm going to label this P, Q, and R. And I'm going to put my reference angle right here. All right. I want you guys to take 3 minutes or less and write down which side is the hypotenuse, which side is the adjacent side, and which side is the opposite side. All right. Just take a minute. Just take a minute. And I'll have some volunteers.
So what was supposed to do, sir?
I want you to label the sides.
Sir, if it's adjacent, sir.
Right. If it's
Okay.
if it's adjacent. So for example,
Sir.
you tell me the letters, the two letters that corresponds to adjacent, opposite, and hypotenuse. Just like we did a while ago. But this was a different triangle.
Sir, me finish.
All right.
So I'm done.
All right. Okay. I want one person to tell me which side is the hypotenuse.
P
And,
R
and hold,
P R.
hold on. And when you tell me, I want you to tell me how you came about, how you identify the side. Just one person.
PR, sir. Reason
Okay.
why is because it's opposite to the right angle.
Very good. So the hypotenuse is PR, and it is the longest side, but more importantly, because these diagrams are not drawn to scale, sometimes these two sides look long, so you just use the relationship that it's opposite the what? The right
That get
angle.
me confused, sir.
Yeah, man, because, yeah. So, all right, what about the adjacent side?
Sir, between the reference and the right angle, sir, PQ, sir.
Very good. So the adjacent side is actually PQ, and as you correctly said, it's always between the reference angle, which is right here, and the right angle. And last but not least, the opposite side would be what?
QR.
QR,
It would be
sir.
QR.
The right angle,
All
sir.
right. All right. And you don't have to give a reason for that because it is just what is being eliminated. Because once you find the hypotenuse and the adjacent, the other side must have been the what? The opposite. All
Okay,
right.
sir.
So based on my experience, it's best to find the hypotenuse first and the adjacent and try to find out and try to eliminate those two to find the opposite. In other words, don't go and try to find opposite, because sometimes some students get mixed up with the opposite. Sometimes the boy, sir, see the opposite there? That's the opposite, but sir, see opposite over there, so the right over there, there, and all that kind of something. So, you know, I don't want you guys to make any error. So don't try to find the opposite first. Find the hypotenuse and the adjacent, because finding the hypotenuse and the adjacent side, we have some foolproof methods. All right? You can't go wrong with that. All right. Do you guys have any questions? All right. So I'm just gonna let's move on. All right. I want somebody to tell me those missing values.
Sir, can you read?
Sir, opposite is
I-
6 over the hypotenuse, which is 10.
Sir, you can repeat, please.
All right. Hold on. All right. Tell me, before you start, you see, look on the screen. You have sine, right? Sine is opposite of hypotenuse, all right? And there's a right angle triangle.
Yes, sir.
Question is, I want you to put in those values. What is the opposite value? What is the hypotenuse value? And give me the answer. So in other words, previously, we were just what? Labeling the sides. Not true?
Yes, sir.
Yes, sir.
We were identifying the sides and put a label to it. But now I'm giving you values. So you're going to do the same thing. You're going to
Sir, if
identify the sides, and then you tell me what the answer is.
Sir, if
Sir, if-
answer 8 are the opposite, sir, and the hypotenuse 10, sir. Opposite to
Okay.
right angle. And
Yes.
the equal to 6? No? Okay,
Well,
sir.
you're correct. The opposite is what?
8.
8.
Then
The
hypotenuse
hypotenuse is what? 10.
10.
Right. So use a calculator and tell me what you get.
As our fraction, decimal, or what, sir?
Just use a calculator. You're gonna get 4 over 5, aren't you? Which is 0.8. All right. I want you guys to work out that for me. Don't show the answers. tell me what cos theta is.
Adjacent sine.
Adjacent 6. Adjacent to
0.6.
All right, 0.6. Who said that? You want to tell me what? All right, you want to tell me what you got for your adjacent?
Adjacent is 6.
Very good. Hypotenuse is
10.
10. 6 divided by 10 is
0.6.
0. Very good. Awesome. All right. Next one, no. Tan. All right. Janet, I thought I saw you a while ago. Are you still there? Okay.
1.333.
Okay, 1.33. So the opposite would have been what?
8.
Adjacent is 6, and you get 1.3. You get a recurrent decimal. All right. Everybody following so far?
Yes, sir.
Yes, sir. Have you answered them, sir?
Hmm?
Sir, I answered them right time, sir. So if we see them next time again, sir, we can know.
Okay. Remember that this recording will be posted on YouTube here. But if you want to
Okay,
write,
sir.
no problem. No problem if you want to write, because sometimes we watch a lot of stuff and we don't really record them. We just have a lot of stuff on our phones, and we're not making use of it. We don't make sense of it. We have one bag of pictures on your phone. All right. Are you through with writing?
Soon, sir.
All right.
Okay, sir.
All right. Thank you. So let's move on. All right. No, it gets interesting now, guys. Right. It gets interesting now. So I want you, well, this topic requires the use of a scientific calculator. So you're supposed to have a scientific calculator. Many students opt to use their phone. And well, I know it's not exam time as yet, but let me encourage you to get one if you don't have one. If you have your scientific calculator, make sure it is in degree mode. You can do a little test to check if your calculator is in degree mode. If you find sine 30 degrees, you will get 0.5. So do that as a check. Just press sine 30, press sine then 30, then you'll have to get 0.5. If you're not getting 0.5, let me know.
Yes, sir. I get 0.5.
And I should also warn you that some phone, when you press sine
Sir, I
sine
can see
30,
your calculator may I use.
all right, you got 0.5?
Yes, sir.
All right, cool. Because sometimes the mode on the calculator changes, right? All right, so
Yes,
let's look at
sir.
this. Look at this question. So it says finding the lengths of sides in a right angle triangle. All right, so you notice that you're given one side on an angle, and you're asked to find the other side. All right, so we're gonna use sine. All right, so maybe next class I'll teach you guys how to determine which of the ratios you're gonna use, whether sine, cos, or tan. But because we're doing this for the first time as a class, we are telling you that to use sine. Now we know that sine is opposite over hypotenuse. All right, so can somebody tell me what should go in the first question sign? It says sine theta. Okay, so
70.
right. So you see the theta, the reference angle, that should go right there. So that always go beside the sign.
Yes, sir.
All right. And then what's gonna go at the other question sign?
20.
20. Right. All right. Can somebody tell me how we're going to find x? What's the next step?
If me no answer, find the hypotenuse and the
We transpose there.
All right. Good. Right. Right. Yeah. I'm on a young lion talk a while ago. Boy, it's good to hear a male speak in this class. I wonder where are the males? Yes, sir. We transpose this formula. We make x the subject, not true? All right.
Yes, sir.
So we're gonna cross multiply.
Yes, sir.
All right.
Instead,
Let me,
yeah, go do opposite.
right. Let me bring up my highlighter. All right. So, boy, this thing is so. I don't even know which part. Okay, it's right up here. All right. So what happened is that we put this over 1 and we cross multiply. So 1 times x gives us x. So end up with 20 times sine 70. All right. So 20 times sine 70. Now sine 70 is 0.9397. Can you double check that for me, please? Press sine 70 on your scientific calculator. Check to see if that's correct.
Yes, sir.
All right. I want you guys to multiply it by 20 and tell me what you get. Give me your answer to 1 decimal, please.
18.8.
18.
18.8.
18.8.
Yeah, 18.8.
All right. All right. Let's see if you're correct. Awesome. Very good. You're learning, man. And this is the basic step. This is the basis of trigonometry. All right? See, it's not so bad. Any questions? All right. No, let me ask a question. Suppose, because sometimes unknown are going to the denominator, not true? Suppose those 20 over
Yeah.
x and not x over 20. The working out is going to be a little bit different. All right? So stick a pin. Anytime the unknown is at the top, we just multiply the two numbers. And if the unknown the bottom, what we do? We're going to divide. All right? So we can use that.
Repeat, sir.
So, all right. So look, anytime you're doing these questions, right? Anytime you're finding unknown sides of triangles using trigonometry, the unknown might be at the top or the numerator, or it could be also at the what? The bottom or the denominator. Now, if the unknown is at the top, just like what we had a while ago, and you want to work this thing out, all we need to do is what? To multiply these two numbers, and it will work all the time. But what if the unknown is at the bottom? Well, we're gonna see what happens next. We're gonna divide. All right. You know, so I want you guys to try this one for me. Yes, man. Try this for me. Give me your answer to 1 decimal, please. I want somebody that want to talk from evening talk. All right. You see one of these evenings, you know what I'm gonna do? I'm gonna say let everybody open the camera. Oh, that sound.
Bad.
Very bad.
Yeah, it says all right. You know what it says? All right.
So
Class,
where's the
listen to
work
me.
out?
Yes, work this out. I said,
Oh,
class.
me-
It's the
you
next
want
class.
you.
Next class, everybody open the camera. Because I want to see you guys. And
Sure,
you
my
want to see
camera
me,
now
right?
work from now.
Camera now work? Okay. All right. Anybody work this out?
Yes,
Yes,
sir.
sir.
All right.
Where today?
One person tell me what the answer is.
6.71.
6 point.
To 2 decimal place.
No, give it to me to 1. It will be 6.7 then.
6.7.
All right. Anybody get the same thing? Is she correct?
Yes, sir.
6.7.
Yes, sir.
All right. So the first question sign, what goes there?
40.
40.
40.
And then we have what? 8.
8.
All right. No, what did I say a while ago? When the unknown the top, what do? We just what?
Divide.
Multiply. Right. So we have
Multiply.
8 times tan 40, which is that. And then 8 times that is 6.7. You're absolutely correct. Awesome. Very good. All right.
Sir, question, sir. Where get this 0.8391, sir? The other one,
That-
8 times 40, sir?
No, man. That's
Fan 40 and you press equal
right.
sign.
Right. That's right. You're so
Okay.
correct. Right. That's the value of tan 40. Very good. Thanks for answering. All right. Anybody else with any more questions? All right. By the way, guys, let me just say this again. You notice that the presentation is actually telling you which one to use, right? All right. By the way, quick question, guys. How do you like the layout of the PowerPoint here? Is it okay?
Yes, sir.
Yeah, man. It bad. How would you get a rating so far?
Sir, 10 out of 10.
10 out of 10. You know, sir, this is actually a project. You know, this was actually a project that I was asked to do for a course that I'm doing to create a PowerPoint. And, you know, and it's amazing. You know, these buttons actually work. You know. All right. So let's quiz time. All right. So it's not like quizzes. All right. So what happened is that the question will be will be sent to you just like this, and you tell me what the answer is. All right. So go ahead for me, work out that for me, and tell me what the answer is. It's 10 questions. Guys, give me 1 minute. Give me 1 minute. All right. Any takers for this one? Yeah. Anybody? Let's sketch what's happening. That's the ground, right? That's a wall. What is leaning on the wall?
The ladder.
A ladder. All right. So that's a ladder. So they said that a ladder that's 5 meters long. The foot of the ladder away from the wall is 3. Where is that? Is it down here or is it up here?
The foot, sir. The base.
The base, right? So this would have been 3. So basically, it says how far up the wall does the ladder reach? In other words, we want to find this, right? We want to find a height right here. So what are we going to use?
Sir, the formula A square.
Right. We're going to use Pythagoras, not true? Yes.
Yes.
What did I say?
Yes, sir.
We only use Pythagoras to find a missing side if the two sides are given. If you notice, there's no angle there, so we can use trigonometry. All right. Now, next question. Is the long side we want to find or a short side?
Long side.
Short side.
It's a short side. Remember, the long side is what? Always what? Opposite the right angle. All right. So it's a short side. So let us set out the formula. So remember, it's a square equals what? Not a square.
A square plus B square equals C square.
Right. A square plus B square equals C square. All right. So we know that A square, A and B are the two short sides, right? So you're gonna have it's gonna be 3 square plus a x square. We don't know what the other side is. And that is equal to what? 5 square. All right. So what we do, we subtract 3 square on the left. All right. And 3 square is 9, not true? So we subtract 9 from the left and what? 9 from the right. All right. So sorry about the mess. All right. So x square. What's 5 square?
25.
25. All right. What's 9 from 25?
16.
And we find the square root of 16. Answer is?
4.
Answer is?
4.
Is 4.
A.
Right.
4.
Right. Very good. Very good. So the answer is A, all right? So, you know that you didn't have to do all of this though. There are some special numbers called the Pythagorean triples. All right? So there are 3, 3, 4, 5. What that mean? You see the 3 and the 4? Those are the two short sides. And the long side is what? 5. So if them give you 3 and then give you 5, the other one must be what? 4. If them give you 4 and 5, the other one must be 3. So for this question, you didn't have to work them out like that. It doesn't work for all numbers. All right. So in 1 second, you could actually just finish this in no time. They're called the Pythagorean triple. Let me tell you another combination.
Sir, repeat that.
All right. So what I'm saying, you see, you have something called Pythagorean triple. It's a special sequence of numbers. All right. Let me erase. Let me erase this thing here. Boy, you see, if it was Zoom, no, I could just write on this thing here. I feel like I'm actually erasing a real board when I'm doing this. It's like it takes forever to come off. I wonder what that them do though. Oh, look there. Look at that. Jeez, All right, so let me explain to you. Pythagorean triple. So let us say you have we have this triangle, right? On one side is 3, one side is 4. And when you do the math, you get 5. All right? So 3 square is 9, plus 4 square is what? 16. 16 plus 9 is 25. The square root of 25 is 5. Now, you see this combination here? 3, 4, and 5? They're called Pythagorean triple. Meaning that if I gave you the 3, if I tell us that one side is 3, and the long side is 5, then the other side must be what? 4, without working it out. It will always work. And another combination is 6, 8, and 10. All right, guys, there's no pattern to it here. So you have 6, 8, 10. In other words, if two short sides are 6 and 8, the other side must be what? 10.
10.
So if them tell us that one side of the triangle is 10, and one next side is 8, the other one must be what? 6.
6.
All right, and you have quite a few more. All right, but these are the very popular one I've seen in CXC. 3, 4, 5, 6, 8, 10. So what I'm saying for this question here, if you know some Pythagoras theorem, right? And look, you see 5 and you see 3, then the other one must be what? 4. All right. Okay, so guys, these buttons actually work, you know. All right, you want to see what happens when you press the wrong button? All right, let's test to see if this actually works. So I'm gonna press D. See that? Right. So it says wrong. So you're gonna try again. So you're gonna press try again button. All right, you get shot a while ago, you know. So anytime you get it wrong, you get shot. All right, let's try another one. Let's try C. C is wrong. Try again. And this is my favorite one, B, when it's wrong. All right. I like this one. All right. All right. Let's try A now. All right. So when you get it right, you just press keep going. All right, let's move on to the next question. Ouch. This one here, look. I don't know. You look away. But see if you can figure it out, all right? Let me give a hint. It's Pythagoras theorem. By the way, these are 6 past paper questions here.
Quick question, Mr. Stevens. Will you be going through like some past papers close to CSEC time?
Yes, man.
Like for revision, right?
Yeah, man. As a matter of fact, you know how I teach. If any assessment is always a CXC past paper. For example, these questions that we're looking at, they're actual past papers. But in terms of going through an entire paper, yeah, man, I will definitely do that. All right, do we have any takers for this one here? Anybody? Anybody want to? Well, the thing about it, if you get a question right, I don't know what to do. What should come to your mind are principles, not true. Question: look at that triangle. What type of triangle is that?
Right angle triangle, sir?
Right.
Right
Question.
angle.
Point number 2. how many sides are given to you?
Three.
Well, no. When I say how many sides are given, probably I should rephrase it. We have two sides that are labeled, not true. In other words, we know them. We know two sides, but even though they are variables, two sides are actually given to us, right? And we're asked to find what? The other side. So AC is given, even though we don't know what is, and BC is given, even though we don't know what is. So what's your conclusion? Let me run it again. Number one, it's a right angle triangle. Point number two, two sides are given. What's the conclusion?
Sorry, sin.
Sin. All right. I hear what you're saying. That sounds like trigonometry, not true? All right, but can somebody tell me? Can somebody tell me why we wouldn't use sine, cos, and tan in this question?
Sir, we're not adjacent nor hypotenuse or opposite sides, sir?
No, so they're there. They're
Sir.
there. Yes, they're there.
Adjacent to the trifine.
Sir, because there's not a definite value for theta.
Exactly. There's no theta. There's no angle there, not true? All right. And then let me be clear. You can actually use trigonometry to find an angle when you're given two sides. So we're given two sides, and you can find an angle. But does the question ask us to find an angle?
No.
No. So let me go back again. Point number one, it's a right angle triangle. Point number two, we're given two sides. Point number three, we're asked to find another side. With which concept are we going to use? Pythagoras. That's where I go. Yes, Pythagoras.
Yes, sir.
In the same one. That man from Greece. Let me see. Look at this question. This was a trigonometry question, you know. Look. One side, one angle. All right? But anytime we're doing Pythagoras, let me go back to Pythagoras. Look at Pythagoras. No, this is still trigonometry. Oh, it's so far gone. Oh dear. All right, you know what? Let me go back. I didn't realize it was so far. All right, so the point I'm trying to make, you see? The point I'm trying to make is that we're given two sides. We're asked to find another side. So therefore we use what? Pythagoras. All right. Then you ask yourself this next question. Which side are we want to find? Is it the long side or the short side? Class? Long side or short side?
Short side.
It's a short side, don't you? Because AB is over here, don't you? That's a short side.
Yes, sir.
Right. So remember, these are the two short sides, you know. Those are the two short sides. And this is the longest side, the hypotenuse. All right. All right. So now that we want to find a short side, let's proceed. So the formula is what? A square plus B square equals C square. So A square, well, A already did it, don't you? So that's A square, which is this, a short side, plus let's call AB B square equals this thing here. So it says square root A square plus 16. Yeah, so what the hell is this? All right, not sure. When I see just a wagwan so. All right, everybody see this now? So this is A square. This is Pythagoras' theorem, you know. This is A square plus B square. So the B square is this part here, AB. So let's call it B square. Equal to, Oh, I missed out something. This should be square, right? That should be square. So, what do we want, guys? We want what? B square. So we have, so what we're going to do is, see, we're going to subtract B square from the left. No, sorry. We want B square, so we need to get rid of what? A square. Right. So we subtract A square on the left and A square on the right. Oh dear, where should I go? Sorry about this. A square. All right. By the way, guys, you realize I made an error a while ago? And this is a common error. We want B square. And you remember this a while ago? What I want, I subtract B square from it. In other words, what I want, I'm getting rid of. What on say go?
Yes, sir.
Yeah, it's a common error. Yeah, it's a common error. So because you want B square, you can subtract B square from B square because you're not going to end up where you want. You will lose what you want. All right? All right. So A square from A square will give us what? 0, don't you? What left back? What left back is what?
B square minus
Square.
A
All right. All right. All right. All right. All right. Okay. Well, mute your mic because it sounds like somebody win lotto a while ago. It's either somebody win lotto a while ago or somebody fight over the lotto ticket. All right.
Sorry, sir.
All right. Okay. All right. No, I want you guys to examine this. I was just joking, man. All right. I will just examine this. What you notice? How do we get rid of a square root, class? By what?
Square rooting.
Here.
No, man. Hold on. No. And hold on. I hear somebody say square root. No, it's not square root. I said listen carefully. Square. So
Square it.
if you want to get rid of a square root,
Finding the square root of it.
no. Listen carefully. Let us say I have the square root of 4, right? Suppose I want this symbol to vanish, the square root symbol. What I would do is what? I would square it. All right? But what if I have a square, 4 square, and I want the square to vanish? What would I do? I would square root it. So if you have a square root, we square it so that the square root vanishes. If, however, we have a square and we want to get rid of the square, what do? We square root it. All right? So over here now, what do we have? We have a square root, don't you? And then the square root is squared. So what's going to happen to this big sign here? It go what? It go?
Come off.
Go come off.
Yes.
Right. You're going to drop off, aren't you? So we have a square plus 16 subtract a square. All right? What's going to happen to these two a squares, ladies and gentlemen? What's a square from a square?
They're going to cancel out.
Going to cancel. Going to give 0. So end up with b square equals what? 16.
16.
So how do you find b? How do I find b? Is b equal to 16?
No, sir. You have to square it. You have to square it.
Right. Very good. We get rid of the square by what? Square rooting. All right. So notice up here, so we had a square root, and we had to square the square root for the square root to vanish. But down here, so we had a what? We had a what? A square, and we're going to have to square root it so that the square vanishes, leaving behind what? B. And we know
Yes,
that
sir.
root. We know that root 16 is. What is root 16?
4.
4. Right. So the answer is 4. So So let's test it. Let's test if it's correct. A. Right, you're 100% correct. And when you finish, just press keep going. All right. So let me see if I can take one more question. Oh my, it's pretty late. All right, guys, we're gonna have to end here. So I'll see you guys. All right. What we're gonna do next class is to finish off. It's 10 questions. So we're gonna finish them off next class. All right. So have a pleasant evening, and I'll see you guys around. All right. And thanks for joining us.
Same to you,
Yes,
sir.
ma'am. Right.